Now there will be some questions in inverse trigonometric functions where we'll need to use conditional identities. Say for example, we are given this question that if sin inverse x plus sin inverse y plus sin inverse z equals pi, then prove that x into under root 1 minus x square plus y into under root of 1 minus y square plus z into under root of 1 minus z square is equal to 2xyz. So what we are given is sin inverse x plus sin inverse y plus sin inverse z equals pi. Now what we'll do is we'll take this as a, we'll take this as b, and we'll take this as c. Then what we are given is, we are given the condition that the value of a plus b plus c, it is pi, where x is sin a, y is sin b, and z is sin c. Now we'll put the value of x, y and z, then we'll get sin a cos a plus sin b cos b plus sin c cos c, and it is 2 sin a sin b sin c. Now we'll multiply with 2 also, then we can write this as 2 sin a cos a, 2 sin b cos b, 2 sin c cos c, and here it will be 4. So now we can write it as sin 2a plus sin 2b plus sin 2c, and it is equal to 4 sin a sin b sin c, which is nothing but conditional identity. So now we are given this condition and we need to prove this conditional identity. So what we'll do is we'll start with using the formula for sin c plus sin d for first two expressions. So it will be 2 and then sin a plus b by 2. So it will be sin a plus b, and then cos a minus b by 2. So it will be cos a minus b plus, now sin 2c is 2 sin c cos c. So we'll write this as 2 sin c into cos c. Now a plus b is pi minus c. So we'll write a plus b as pi minus c. Now sin pi minus c is sin c. So we'll take 2 sin c common, and then we'll get cos a minus b plus cos c. Now again we'll write this cos c as cos a minus b, and plus c is pi minus a plus b. So it will be pi minus a plus b, which is 2 sin c cos a minus b. Now cos pi minus theta is minus cos theta. So it will be minus cos a plus b. Now we'll use the formula for cos c minus cos d. We'll get 2 sin c plus d by 2, and then sin d minus c by 2. So which is 4 sin a sin b and sin c, which is the result that we need to prove. So this question, it's actually a conditional identity question. It is just that they have asked the question in inverse trigonometric form. Now another question could be, if tan inverse x plus tan inverse y plus tan inverse z equals pi, then prove that x into 1 minus y square into 1 minus z square plus y into 1 minus z square 1 minus x square plus z into 1 minus x square into 1 minus y square is equal to 4xyz. Now as we did in the previous question, we'll take this as a, we'll take this as b, and we'll take this as c. So here we'll get x equals tan a, y equals tan b, and z equals tan c. And also we'll get this condition that a plus b plus c, it is equal to pi. Now we'll need to prove this statement. Now what we'll do here is we'll divide everything with 1 minus x square, 1 minus y square, and 1 minus z square. Then we can write this as x upon 1 minus x square plus y upon 1 minus y square plus z upon 1 minus z square, and here it will be 4 x upon 1 minus x square, y upon 1 minus y square, and z upon 1 minus z square. Now what we'll also do is we'll multiply everything with 2. So here will be 2, 2 and 2, and here also we'll multiply it with 2. So it will become 8. So now we can write this as 2x, 2y and 2z. Now we'll put x as 10a. This is 210a upon 1 minus 10 square a, which is nothing but 10 2a. So we can write this as 10 2a. This will be 10 2b. This is 10 2c. And here we'll get 10 2a into 10 2b into 10 2c. So now the question becomes, if a plus b plus c is pi, then prove that 10 2a plus 10 2b plus 10 2c equals 10 2a into 10 2b into 10 2c. So we'll start from here. We'll write a plus b as pi minus c. We'll multiply by 2. We'll write 2a plus 2b equals 2 pi minus 2c. Now we'll take 10 both sides. We'll write 10 2a plus 2b, and it'll be equal to 10 2 pi minus 2c. Now this is 10a plus b, so we can write this as 10 2a plus 10 2b upon 1 minus 10 2a into 10 2b. Now 10 2 pi minus theta is minus 10 theta, so it will be minus 10 2c. Now we'll cross multiply. We can write this as 10 2a plus 10 2b, and it'll be minus 10 2c plus 10 2a into 10 2b into 10 2c. So we'll take this 10 2c on the left hand side. We can write 10 2a plus 10 2b plus 10 2c. It will be equal to 10 2a into 10 2b into 10 2c, and this is what we need to prove. So this is how we solve such questions. Now here the question is, if the range of the function fx equals sine inverse of x plus 2 tan inverse of x plus x square plus 4x plus 1 is included p to included q, then find the value of p plus q. Now we know that domain of this function is x belongs to minus 1 and plus 1. If we'll differentiate this function, we'll get f dash x as 1 upon under root of 1 minus x square plus 2 upon 1 plus x square, and then 2 into x plus 2. Now this is positive, and when x lies between minus 1 and plus 1, x plus 2 is also positive. So that means this f dash x is always greater than 0. It simply means that this fx is an increasing function. Now fx is continuous and fx is increasing. So if the function is continuous and increasing, it will attain its minimum value at the start of interval, and it will attain its maximum value at the end of this interval. So minimum value of this function will be when the value of x is minus 1. Now we'll put x as minus 1. It'll be sine inverse minus 1, which is minus pi by 2 plus 2. Tan inverse minus 1 is minus pi by 4, and then plus 1 minus 4 plus 1, and this value, it will be minus pi minus 2. And maximum value of this function, it will be when the value of x is 1. If we'll put x as 1, we'll get this as pi by 2 plus pi by 2, and 1 plus 4 plus 1. So it'll be simply pi plus 6. Now this is your p, and that's your q. Now we need to find the value of p plus q. So value of p plus q, it will be minus pi minus 2 plus pi plus 6. Now pi and pi will cancel. So this value is simply 4. So the value of p plus q is simply 4, and that is the answer to this question. Now here the question is, find the minimum value of this function fx equals pi square upon 16 cot inverse of minus x minus cot inverse of x. Now what we'll do is we'll add pi and subtract pi, and we know that pi minus cot inverse of x is cot inverse of minus x. So we'll write this function fx as pi square upon 16 cot inverse of minus x plus cot inverse of minus x minus pi. Now we need to find minimum value of this function. Now we know that a range of cot inverse of minus x is from 0 to pi. So it is a positive number. So what we'll do is we'll take these two numbers and we'll find their AM and GM. So arithmetic mean of these numbers will be pi square upon 16 cot inverse minus x plus cot inverse of minus x by 2, and it'll be greater than or equal to their geometric mean, and their geometric mean will be simply pi by 4. Now what we'll do is we'll multiply this 2. So we'll write pi square upon 16 cot inverse of minus x plus cot inverse of minus x is greater than or equal to pi by 2, and then we'll subtract pi on both sides. Now this is nothing but fx. So from here we'll get this condition that this fx is always greater than or equal to minus pi by 2. So the minimum value of this function will be minus pi by 2, and that is the answer to this question. Now here the question is find the minimum value of secant inverse x square plus cosec inverse x square. We can solve it using quadratic expressions, and for that what we'll do is we'll write this as y equals secant inverse of x square, and then we'll write cosec inverse of x as pi by 2 minus secant inverse of x whole square. So now it will become a quadratic in secant inverse of x. So it will be 2 secant inverse of x minus pi secant inverse of x plus pi square by 4. Now we'll take 2 common. So we'll get y equals secant inverse of x whole square minus pi by 2 secant inverse of x plus pi square by 8. Now what we'll do is we'll complete this perfect square, and for that we'll add pi square by 16 and we'll subtract pi square by 16. So we'll write this as y equals 2 into secant inverse of x minus pi by 4 whole square, and then here it will be plus pi square by 8. Now this expression is always positive, that is greater than or equal to 0. So from here we'll say value of y is always greater than or equal to pi square by 8. So the minimum value of secant inverse x square plus cosec inverse x square is pi square by 8. Now there will be some questions where we need to find greatest and least value of inverse trigonometric functions. Now in this case we have to find the range of this function, which is say fx, and that is sin inverse of x square plus cos inverse of x square when the value of x lies between minus 1 and plus 1, which is the domain of this function. Now for such questions there are two different ways. Now the first method is using quadratic expressions. So what we'll do is we'll write this function fx as sin inverse of x square, and then we can write cos inverse of x as pi by 2 minus sin inverse of x square. Now we can solve the squaring and we can express this as a quadratic expression in sin inverse of x. So it will be 2 sin inverse of x minus pi sin inverse of x plus pi square by 4. Now we'll take 2 common. So we'll get 2, and then it'll be sin inverse of x square minus pi by 2 sin inverse of x plus pi square by 8. Now what we'll do is we'll complete this perfect square. So we'll add pi square by 16 and we'll subtract pi square by 16. So we can write this function fx as 2 sin inverse of x minus pi by 4 whole square, and then plus pi square by 8. Now for the least value of this function, the value of this expression in square, it should be 0. So minimum value of this function, it will be simply pi square by 8. Now for maximum value, we have to find the maximum value of this expression within the square. Now it will attain its maximum value when the value of sine inverse of x is minus pi by 2. So we'll put sine inverse of x as minus pi by 2. We'll get this as 2, and then minus pi by 2 minus pi by 4. It'll be minus 3 pi by 4, and we'll square it. We'll get this as 9 pi square by 16, and plus pi square by 8. So it'll be 20 pi square by 16, which is 5 pi square by 4. So minimum value of this function is pi square by 8, and maximum value of this function is 5 pi square by 4, which is your option 3. And if we have to find range of this function will be from pi square by 8 to 5 pi square by 4. Now another method to solve this question is using calculus. So we'll find f dash x. We'll write this as 2 sine inverse of x upon under root 1 minus x square and minus 2 cos inverse of x upon under root 1 minus x square, and we'll put it equals to 0. We'll get sine inverse of x equals cos inverse of x, that is the value of x should be 1 by root 2. So now we have three critical points: x equals minus 1, x equals plus 1, and x equals 1 by root 2. Now since this function is continuous and differentiable, it will attain its absolute minimum and maximum at these points. So we'll find these values. So we'll put x as minus 1. We'll get this function fx as, now sine inverse minus 1 is minus pi by 2, and minus pi by 2 square is pi square by 4, plus cos inverse x. Now cos inverse of minus 1. Cos inverse of minus 1 is pi. So it'll be simply pi square. So we'll get this value as 5 pi square by 4. Now we'll put x as 1. Then sine inverse 1, it'll be pi by 2. So it'll be pi square by 4. And then plus cos inverse of 1. And cos inverse 1 is 0. So it'll be pi square by 4. And finally, if we'll put x as 1 by root 2. So sine inverse 1 by root 2 is pi by 4. So it'll be pi square by 16 plus pi square by 16. And it'll be pi square by 8. Now the least value is pi square by 8. And the maximum value is 5 pi square by 4. So range of this function is from pi square by 8 to 5 pi square by 4. And that is the answer to this question. Now here the question is, prove that the equation sin inverse x cube plus cos inverse x cube equals alpha pi cube has no roots if alpha is less than 1 by 32 and alpha is greater than 7 by 8. Now what we'll do is, we'll take this function fx as sin inverse of x cube plus cos inverse of x cube, and we know that domain of this function is from minus 1 to plus 1. Now this function is continuous and differentiable, so we'll find its range. Now we'll differentiate, we'll find f dash x, we'll get 3 sin inverse of x square upon under root of 1 minus x square minus 3 cos inverse of x square upon under root of 1 minus x square equals to 0, and then we'll get sin inverse of x equals plus or minus cos inverse of x. Now we'll take plus sign, sin inverse of x equals cos inverse of x, and which is true when the value of x is 1 by root 2. And we'll take the second case when sin inverse of x is minus cos inverse of x, we'll get sin inverse of x plus cos inverse of x equals 0, which is not possible. So the only critical point that we get from here is x equals 1 by root 2. Now we'll find absolute maxima and absolute minima. So we'll find the value at minus 1, we'll find the value at plus 1, and we'll find the value at 1 by root 2. Now we'll put x as minus 1. So it'll be sin inverse minus 1, which is minus pi by 2. So it'll be minus pi cube by 8 plus cos inverse minus 1, and cos inverse minus 1 is pi cube. So we'll get this as 7 pi cube by 8. If we'll put x as 1, we'll get this as pi cube by 8, and then cos inverse 1 is 0, so we'll get this as pi cube by 8, and value of this function, when the value of x is 1 by root 2, it will be sine inverse 1 by root 2, which is pi by 4, so it will be pi cube by 64 plus pi cube by 64, so it will be pi cube by 32. Now out of these three, this is the minimum value and that is the maximum value. So range of this function, it is from pi cube by 32, comma 7 pi cube by 8. Now this equation, it will have a solution when alpha pi cube will lie in the range of this given function. So this will have a solution if pi cube upon 32 is less than equal to alpha pi cube is less than equal to 7 pi cube by 8. Now we can cancel pi cube. So this equation will have a solution when the value of alpha lies between 1 by 32 to 7 by 8. And to put it other way, we can say that this equation will have no solution if alpha is less than 1 by 32 or when alpha is greater than 7 by 8. And this is how we solve such questions. Now here the question is, we are given this function fx, which is tan inverse of x cube plus cot inverse of x cube when x belongs to R, and we need to find its range. Now again, tan inverse x is continuous and differentiable, and cot inverse x is also continuous and differentiable. So this function, it is both continuous and differentiable. Now we'll find its critical points. So we'll find f dash x, and it'll be 3 tan inverse of x square upon 1 plus x square, and minus 3 cot inverse of x square upon 1 plus x square. And if we'll put it equals to 0, we'll get this as tan inverse of x equals plus or minus cot inverse of x. Now we'll take minus sign, we'll get tan inverse of x plus cot inverse of x is 0, which is not possible. So that means the only solution that we'll get is when the value of tan inverse x is equal to the value of cot inverse x, and which simply means that the value of x here should be 1. So now we have three critical points: when x approaches minus infinite, when x approaches plus infinite, and when the value of x is 1. So we'll find the value at minus infinite. Now tan inverse minus infinite is minus pi by 2. So it'll be minus pi by 2 cube and then plus. Now cot inverse minus infinite is pi. So it'll be pi cube. So we'll get this value as pi cube minus pi cube by 8, which is 7 pi cube by 8. Now we'll put limit x tends to infinite. Tan inverse infinite will be pi by 2, so it will be pi cube by 8, and then plus cot inverse infinite is simply 0. So there will be pi cube by 8, and finally the value at 1. Value at 1 is tan inverse 1. So there will be pi by 4, and pi by 4 cube will be pi cube by 64 plus pi cube by 64, which is pi cube by 32. So its minimum value is pi cube by 32 and its maximum value is 7 pi cube by 8, which occur at minus infinite. So range of this function, it will be from included pi cube by 32 to not included 7 pi cube by 8. Now this is A and this is B. Now we need to find the value of B upon 7a. Now b is 7 pi cube by 8 upon, now 7 and a is pi cube by 32. Now 7 pi cube will cancel, and this value, it is equal to 4. So the value of b upon 7a is simply 4, And that is the answer to this question. Now here the question is, if this equation 2 to the power 2 pi upon cos inverse x minus a plus 1 by 2 to the power pi upon cos inverse x minus a square equals to 0 has only one real root, then which of the following options is or are correct? Now what we'll do is, we'll take this y as 2 to the power pi upon cos inverse of x. So we can write this equation as y square minus a plus 1 by 2y and minus a square equals to 0. And we'll take its corresponding quadratic expression fy, which is y square minus a plus 1 by 2 minus a square. Now when we look at this y is 2 to the power pi upon cos inverse of x. Now what we know is, we know that value of cos inverse of x lies between 0 and pi. Now we'll take reciprocal, we'll get infinity is greater than 1 upon cos inverse of x. It is greater than equal to 1 upon pi. Now we'll multiply with pi. So we'll get 1 is less than equal to pi upon cos inverse of x is less than infinite. Now we'll take it to the power of 2. So we'll get 2 is less than equal to 2 to the power of pi upon cos inverse of x is less than infinite, and this is nothing but y. So value of y is greater than or equal to 2. So for this function, value of y is greater than or equal to 2. Now it says this equation has only one real root. So it simply means that this quadratic expression, which is quadratic expression opening upwards, it should intersect x-axis only at one point after y equals 2. So it simply means that this 2, it should lie in between the roots. So the only condition that we'll get from here is value of f2 should be less than or equal to 0. Now we'll put y as 2, we'll get this as 4 minus a plus 1 by 2 into 2 minus a square. Here it should be y minus a square, and it is less than or equal to 0. So we write 4 minus a minus 1 minus a square is less than equal to 0. So we'll get this as a square plus a minus 3, it is greater than or equal to 0. So we can write this as a plus 3 a minus 1 greater than equal to 0. Now the critical points are minus 3 and 1. So this is plus, minus and plus. So either it is less than or equal to minus 3 or greater than or equal to 1. So the value of a should be either less than or equal to minus 3 or the value of a is greater than or equal to 1. That means options B and C. Now the question is, if the equation sin inverse x square plus x plus 1 plus cos inverse lambda x plus 1 equals pi by 2 has exactly two solutions for lambda belongs to a comma b, then the value of a plus b is. Now first we'll write conditions of domain. So this x square plus x plus 1 should be greater than minus 1 but less than 1. Now this expression is always positive, so it is always greater than minus 1. So we just have to solve the second part. So from the second part we'll get x square minus x is less than equal to 0. That is x into x plus 1 is less than equal to 0. So this is minus 1, 0. This is plus, minus or plus. So this first part, it will be defined when the value of x lies between minus 1 and 0. Now this expression is an identity. Sin inverse x plus cos inverse x equals pi by 2. So this equation will hold when x square plus x plus 1 is equal to lambda x plus 1, that is x square plus 1 minus lambda x equals 0, that is when the value of x is 0 or when the value of x is lambda minus 1. Now this equation should have exactly two solutions. Now one of the solution is x equals 0 and the other solution should be x equals lambda minus 1, and this solution is valid when this value of x lies between minus 1 and 0, and since we already have 0, 0 is not included here. So this equation will have a solution when the value of lambda minus 1 will lie between minus 1 and not included 0. That is when the value of lambda lies between 0 and 1. So this equation will have exactly two solutions when lambda belongs to 0 to 1. Now we need to find the value of a plus b. Now a is 0 and b is 1. So the value of a plus b is simply 1, and that is the answer to this question. Now here the question is, show that the roots r, s and t of cubic x into x minus 2 into 3x minus 7 equals 2 are real and positive. Also compute the value of tan inverse r plus tan inverse s plus tan inverse t. Now what we'll do is, we'll take this function fx as x into x minus 2 into 3x minus 7, and we'll take this line y equals 2, and we need to show that these two graphs, they'll intersect at 3 distinct points, and for all these points the value of x will be positive. So we'll draw this graph. So here the roots are 0, 2 and 7 by 3. So we'll draw a rough sketch. Now we need to draw this y equals 2 line. Now this y equals to 2 line, it could be either above this maximum value or it could be less than this maximum value. So if it is the second case, then it will have 3 distinct real roots and which are positive. And the first case, it will have only 1 real root. We need to show that the maximum of this function is greater than 2. Now we'll find f1. f1 will be 1 into minus 1 into minus 4. It is 4. So this function between 0 and 2 takes a value which is 4, which is greater than 2. That means y equals to 2 line will be drawn like this. So now here we have 3 point of intersections, and all these point of intersections, they lie on positive x-axis. So this equation, it will have 3 real roots which are positive. Now it is given that roots are r, s and t. Now we need to find the value of tan inverse r plus tan inverse s plus tan inverse t. Now we know that this is tan inverse s1 minus s3 upon 1 minus s2. Now we need to find s1, s2 and s3, and for that we have to write this as polynomial equation. So we'll multiply, we'll get this as x, and it'll be 3x square minus 6 minus 13x plus 14 equals 2. So it'll be 3x cube minus 13x square plus 14x minus 2 equals 0. So value of s1 is 13 by 3, value of s2 is 14 by 3, and value of s3 is 2 by 3. So we'll put the value of s1, s2 and s3. So it'll be tan inverse. Now what is s1? s1 is 13 by 3 minus 2 by 3 upon 1 minus 14 by 3. So here it will be tan inverse. Now this is 11 by 3, and here it will be minus 11 by 3. So this value is tan inverse of minus 1. Now tan inverse of minus 1, which actually is minus pi by 4, but in this case this value cannot be minus pi by 4, as when r, s and t, they are all positive. So this value will lie between 0 to pi by 2. So here this value will be not minus pi by 4 but 3 pi by 4. So answer to this question is simply 3 pi by 4. Now question number 12 is, the number of real solutions of the equation sine inverse the summation x to the power j plus 1 minus x summation x by 2 to the power I is equal to pi by 2 minus cos inverse summation minus x by 2 to the power I minus summation minus x to the power I lying in the interval minus 1 by 2 to plus 1 by 2 is. Now we look at these 4 summations, then this summation I varies from 1 to infinite x to the power I plus 1, it is nothing but a geometric progression which starts from x square and then it goes x square x cube up to infinite. So its sum will be x square upon 1 minus x. Now the second summation, which is I varies from 1 to infinite, x by 2 to the power I, it starts with x by 2 and then it'll be x by 2 square up to infinite, which again is infinite geometric progression. So its sum will be x by 2 upon 1 minus x by 2, which is x upon 2 minus x. Now this third summation, which is summation I varies from 1 to infinite minus x by 2 to the power I, it will be minus x by 2 plus minus x by 2 square, and its sum will be minus x by 2 upon 1 plus x by 2, which is minus x upon 2 plus x. And then finally we have this summation, which is I varies from 1 to infinite minus x to the power I, which is minus x plus x square minus x cube, will be minus x upon 1 plus x. Now what we'll do is we'll put the value of these four summations in this given equation. Then we'll get sine inverse. Now this first summation is x square upon 1 minus x into summation x by 2, which is x into 2 minus x, and it'll be pi by 2 minus cos inverse. Now the first summation is minus x upon 2 plus x, and then minus and minus will be plus x upon 1 plus x. Now we'll simplify this. We can write this as sine inverse. We'll take x square common and then we'll get 1 minus x into 2 minus x minus 1 plus x, and then pi by 2 minus cos inverse is nothing but sine inverse. So it'll be sine inverse, and then we'll take x common. We'll get 2 plus x minus 1 minus x upon 2 plus x into 1 plus x. Now here x and x will cancel, and here also x and x will cancel. So we can write this as sine inverse x square upon x square minus 3x plus 2, and it'll be equal to sine inverse x upon x square plus 3x plus 2. Now we'll cancel sine inverse with sine inverse, as sine inverse is a 1-1 function. So here x square and x will cancel. So one of the solution that we'll get is x equals 0. And then we have this cubic equation, which will be x cube plus 3x square plus 2x, and it'll be equal to x square minus 3x plus 2, which we can write as x cube plus 2x square plus 5x minus 2 equals 0. Now we'll need to find out how many roots does this equation have when x lies between minus 1 by 2 and plus 1 by 2 as given in the question. Now we look at this function fx, which is x cube plus 2x square plus 5x minus 2, and if we'll differentiate it, we'll get 3x square plus 4x plus 5. Now in this case, coefficient of x square is positive and the value of d is 16 minus 60, which is less than 0. So here f dash x is always positive for all x belongs to R. That means this function is strictly increasing. So this function will strictly increase and it will intersect x-axis at only one point. So this equation will have exactly one real root. Now we need to find out whether this root, it lies between minus 1 by 2 and plus 1 by 2. If it lies between the interval, then we'll have additionally one more root with x equals to 0. Otherwise, we'll have only one root. Now we'll find f0. Value of f0 is minus 2. And we'll find f1 by 2, f1 by 2 is 1 by 8 plus 1 by 2 plus 5 by 2 minus 2, which is greater than 0. So value at 0 is negative and value at f1 by 2 is positive. So that means this graph, it will intersect x-axis between 0 and 1 by 2. So this equation will have one more root in minus half to plus half. And therefore, this equation will have altogether two real solutions in the interval minus 1 by 2 to plus 1 by 2. So answer to this question is simply 2. Now here the question is, find the values of a for which sin inverse x equals mod of x minus a will have at least one solution. Now what we'll do is, we'll draw the graph of y equals sin inverse of x and y equals mod of x minus a, and we'll try and vary a until we get at least one point of intersection. So we'll draw the graph of y equals sin inverse of x. Now this is minus 1 plus 1 and this is minus pi by 2 and plus pi by 2. Now the graph of mod of x minus a will be graph of y equals to mod x, and then we'll shift the graph minus a units along x-axis. So if we'll shift this graph, it will have at least one point of intersection till this arm of modulus function, it passes through this point, and this point is 1 comma pi by 2. Now we'll take a as a negative number. In that case also we'll shift the graph. Then also it will intersect at some point. Now I'll keep intersecting this graph of sin inverse till again it'll pass through this point 1 comma pi by 2. So we'll get range of a for which these two graphs, they'll intersect at least one point, that is they'll have at least one solution. And for both of them, this graph of y equals mod x minus a, it must pass through this point which is 1 comma pi by 2. So we'll put y as pi by 2 and x as 1. So we can write pi by 2 equals mod of 1 minus a, which we can write as a minus 1 equals plus or minus pi by 2. Value of a is plus minus pi by 2 plus 1. So the range of a will be, a should lie between minus pi by 2 plus 1 to plus pi by 2 plus 1, and that is the answer to this question. Now here the question is, find the integral values of k for which system of equation possesses solution and find these solutions. Now this is cos inverse of x and this is sin inverse of y whole square. Now what we'll do is, we'll take this as a and we'll take this as b. So what we're given is, we are given a plus b equals k pi square by 4, and we are given a into b equals pi to the power 4 upon 16, where a is cos inverse of x and b is sin inverse of y whole square. Now clearly range of cos inverse of x is from 0 to pi, and range of sin inverse of y will be from 0 to pi square by 4. So this expression k pi square by 4, it should be greater than 0, which implies that value of k should be greater than 0. So k is an integer which is greater than 0. Now first we need to find value of k, and for that what we'll do is, we'll find this a by eliminating b. So we can write this as a plus, now it'll be pi to the power 4 upon 16a minus k pi square by 4 equals 0. So we'll write a square minus k pi square by 4 into a plus pi to the power 4. We'll solve this quadratic equation to find the value of a. So value of a will be k pi square by 4 plus minus under root of k square pi to the power 4 upon 16 minus 4 pi to the power 4 upon 16 whole divided by 2. Now what we'll do is we'll take pi square by 4 common. So we can write this a as pi square by 8 and k plus minus under root of k square minus 4. Now this equation must have real roots. That means the value of k square minus 4 should be greater than or equal to 0. That is, value of k should be greater than or equal to 2, provided that k is a positive number. So one condition that we get is this value of k should be greater than or equal to 2. Now this a is nothing but a is cos inverse of x. So we can write cos inverse of x as pi square by 8 k plus minus under root of k square minus 4, and the range of cos inverse of x is from 0 to pi. So this value, it should be less than or equal to pi. Now we can write this as k plus minus under root of k square minus 4 should be less than or equal to 8 upon pi, or we can write this as under root of k square minus 4 should be less than or equal to 8 upon pi minus k. Now we'll square it, we'll get k square minus 4 is less than or equal to 64 upon pi square plus k square minus 16k upon pi. Now here k square will cancel, so we'll get 16k upon pi is less than or equal to 64 upon pi square plus 4. Now we'll multiply and divide with pi by 16. So we'll get k is less than or equal to 4 upon pi plus pi upon 4. Now 4 upon pi is 1.274 and pi by 4 is 0.785. So this value is 1.274 plus 0.785, which is nearly 2.059. So the condition that we are getting is this k has to be greater than or equal to 2, but less than or equal to 2 point something. So this equation will have a solution when the value of k is simply 2. Now if the value of k is 2, we can simply write cos inverse of x as pi square by 8 into 2 and then plus minus 0. So x will be cos pi square by 4. And if we'll put cos inverse x as pi square by 4, we can find the value of y also. So pi square by 4 into sin inverse y whole square is equal to pi to the power 4 upon 16. So here pi square will cancel. This 4 will cancel. We'll get sin inverse y as plus or minus pi by 2. In that case, value of y will be simply plus or minus 1. So this equation will have two solutions when the value of k is 2, and the solutions are x equals cos pi square by 4 and y equals to 1, and the other solution is when x equals cos pi square by 4 and y equals minus 1. Now here the question is, find x satisfying this equation, greatest interior function of tan inverse of x plus greatest interior function of cot inverse of x equals to 2. Now we know that range of tan inverse of x is minus pi by 2 to plus pi by 2, and a range of cot inverse of x is from 0 to pi. So the possible values of greatest interior function of tan inverse of x, they are minus 2, minus 1, 0 and 1. So we have 4 values, and greatest interior function value of cot inverse of x, it will be 0, 1, 2 and 3. So we have 4 possible values for greatest integral function of cot inverse of x also. Now we need their sum to be 2. Now this sum, it can be 2 when case 1, when greatest integral function of cot inverse x, it is 3, and greatest integral function of tan inverse x is -1. Second case, when greatest integral function of cot inverse x is 1 and greatest integral function of tan inverse x is also 1. And then finally, this third case when greatest integral function of cot inverse x is 2 and greatest integral function of tan inverse x is 0. Now we need to find simultaneous solutions for these conditions. Now cot inverse x equals 3 means a value of cot inverse, it should lie between 3 and 4. Now cot inverse, it is a decreasing function. So we'll take cot, then sine will decrease. So we'll get cot 3 is greater than equal to x is greater than cot 4. And here, when the value of tan inverse x is -1, that means value of tan inverse of x, it should lie between -1 and 0. If we'll take 10, so we'll get minus tan 1 is less than equal to x is less than 0. Now we'll need to find simultaneous solution of these two conditions. And for that, we'll need to compare the values of cot 3 and minus tan 1. And what we'll do is, we'll draw the graph of tan inverse of x and we'll draw the graph of cot inverse of x. So for tan inverse, we have asymptotes at minus pi by 2 and plus pi by 2. That is the graph of tan inverse of x. So this is minus pi by 2 and this is plus pi by 2. And then for the graph of cot inverse, we have asymptotes at 0 and pi. Now these two graphs, they'll intersect at 1 and this value is pi by 4. Now if we'll draw a line at 3, this point is cot 3, and if we'll draw a line at -1, this point is minus tan 1. So clearly cot 3 is less than minus tan 1. So this first interval is from cot 4 to cot 3 and this second interval is from tan 1 to 0. So there is nothing common between the two intervals. So in the first case, there is no simultaneous solution. Now for the second case, when cot inverse of x is equal to 1 and tan inverse of x equals 1. So in this case, cot inverse, it will lie between 1 and 2 and tan inverse will also lie between 1 and 2. Now here, if we'll take cot, so we'll get cot 1 is greater than equal to x is greater than cot 2, and here tan 1 is less than equal to x is less than tan 2. Now we'll need to compare the values of tan 1 and cot 1. Now we'll draw a line at 1. Here we'll get tan 1 and just before this one we'll get cot 1. So value of cot 1 is less than value of tan 1. So this first interval is from cot 2 to cot 1 and the second interval is from tan 1 to tan 2. There is nothing common again between the two intervals. So for this second case also we'll get no solution. Now we'll come to this third and final case when the value of cot inverse of x lies between 2 and 3 and the value of tan inverse of x lies between 0 and 1. Now in this case, we'll get this as cot 2 is greater than x is greater than cot 3, and here we'll get this as 0 is less than x is less than tan 1. So we already have tan 1. Now we'll need to figure out cot 2. Now we'll take cot 2. Now 2 will be greater than pi by 2. So cot 2 it will again be less than 0. So in this interval again, we are having values in the negative x, and the second interval is between 0 and 10, 1, which is on the positive side. So again, we do not have any common value between the two intervals. So here again, we have no solution. So this equation, greatest integral function of tan inverse x plus greatest function of cot inverse x equals to, it doesn't have any solution. So answer to this question is no solution. Now let us take another example, and which is if the area enclosed by the curves fx equals cos inverse of cos x and gx equals sin inverse of cos x when x belongs to 9 pi by 4 to 15 pi by 4 is a pi square upon b, then we need to find the value of a minus b. Now this function cos inverse of cos x, it is a standard function, and we know how to draw the graph of cos inverse of cos x. So we'll draw this graph. So this is 0 to pi, 2 pi, 3 pi, 4 pi. So this is 0, pi, 2 pi, 3 pi and 4 pi, and here this value is pi. Now this function cos inverse of cos x, it is a periodic function with fundamental period 2 pi. Now we'll draw the graph of sin inverse of cos x. Now we know that sin inverse x is pi by 2 minus cos inverse x. So we can write this is pi by 2 minus cos inverse of cos x. So basically graph of gx is pi by 2 minus cos inverse of cos x. So we'll draw the graph of gx. Now here our basic graph is cos inverse of cos x. First we'll draw the graph of y equals minus cos inverse of cos x. So it will be this graph 0, pi, 2 pi, 3 pi, 4 pi, and here this value will be minus pi, and then we'll take the transformation y minus pi by 2 equals minus cos inverse of cos x. Now y minus pi by 2 means we have to shift this entire graph pi by 2 units along positive y-axis. Now we shift this graph pi by 2 units along positive y-axis. We'll get this graph as this. So this is 0. It'll be pi by 2. This is pi, 2 pi, and here it will be pi by 2 and minus pi by 2. So that is the graph of sin inverse of cos x. So we'll draw the graph of sin inverse of cos x. So this is pi by 2 and this is minus pi by 2. This is pi by 2, pi, 3 pi by 2 and 2 pi. That is the graph of y equals sin inverse of cos x. Now this is minus pi by 2 and this is plus pi by 2. Now this function again, it is a periodic function with the period 2 pi. Now we need to find area between these two graphs in the interval 9 pi by 4 to 15 pi by 4. Now we can actually write 9 pi by 4 as 2 pi plus pi by 4, and we can write 15 pi by 4 as 2 pi plus 7 pi by 4. Now since both the functions, they are periodic with the period 2 pi, so what we'll actually do is, rather than solving this function from 9 pi by 4 to 15 pi by 4, we'll find this area from pi by 4 to 7 pi by 4, which is from this point pi by 4, and 7 pi by 4 is 2 pi minus pi by 4, so which is this point. So we'll need to find this area. Now this point here is 7 pi by 4. This again is pi by 4. this value is pi. So this height is pi minus pi by 4, which is 3 pi by 4. And here, this height, it will be pi by 2 plus pi by 4, which again is 3 pi by 4. So this required area, it will be 1 by 2 and then length of the base. Length of the base is 7 pi by 4 minus pi by 4, which is 6 pi by 4. That is 3 pi by 2 into this height, which is 3 pi by 4 and plus half. Now again, length is 3 pi by 2 and height again is 3 pi by 4. So this area, it will be 9 pi square by 8. So comparing with the given value of A is 9 and value of B is 8, then the value of A minus B is simply 1, and that is the answer to this question. Now here the question is, let fx equals log sin x and gx equals sin inverse e to the power minus x if alpha is a positive real number such that alpha equals f of g dash alpha and b is f of g alpha, then which of the following option is correct? Now first what we'll do is, we'll find this b, which is f of g alpha. Now f of g alpha will be f and then g alpha, and it'll be simply log sin inverse e to the power minus alpha. Now sin and sin inverse, they'll cancel, and log and e, they'll also cancel. So we'll simply get this as minus alpha. So the value of b is minus alpha, and a is nothing but a is derivative of f of g alpha. Now we'll differentiate it with respect to alpha. We'll get this as minus 1. Now we'll find a alpha square minus b alpha minus a. Now a is minus 1, so it'll be minus 1 into alpha square minus, now what's the value of b? B is minus alpha into alpha, and then minus a is minus 1, so it'll be minus alpha square plus 1. So this value will be equal to 1. So answer is a alpha square minus b alpha minus a is equal to 1, and that's your option B. Now here the question is, find the number of solutions to this equation, which is sin inverse 1 plus x square upon 2x and pi by 2 secant x minus 1. Now what we'll first do is, we'll try and simplify this expression on the left hand side. Let it be equal to y, which is sin inverse 1 plus x square upon 2x. Now what we'll do is, we'll let x as some tan theta, then y, it will be sin inverse 1 plus tan square theta upon 2 tan theta, which is sin inverse of cosec 2 theta. Now here we have a problem. We know that value of cosec 2 theta is either greater than or equal to 1 or less than or equal to minus 1, whereas the domain of sin inverse is from minus 1 to plus 1. So this equation, it will only make sense if value of cosec 2 theta is plus 1 or minus 1. Now we'll put cosec 2 theta is plus or minus 1. It will simply mean that this 1 plus x square upon 2x, it should be plus or minus 1. So we'll solve this. We'll get the value of x is plus 1 or minus 1. So for this function on the left hand side, domain is either the value of x is minus 1 or the value of x is plus 1. So this equation is defined only for two values, when the value of x is minus 1 and when the value of x is plus 1. So what we'll do is, we'll check the validity of this equation at both these points. Now we'll put x as minus 1. On the left hand side, we'll get this as sin inverse minus 1, and on the right hand side, we'll get this as pi by 2 secant minus 2. Now sin inverse minus 1 is minus pi by 2, and here we'll get this as pi by 2 secant 2. Now the value of secant 2 is unequal to minus 1. So that means at x equals to minus 1, left hand side, is not equal to its right hand side. Now we'll check the validity when the value of x is 1. So we'll put x as 1, we'll get this as sine inverse 1, and it'll be pi by 2 secant 0, and secant 0 is 1. So sine inverse 1 is pi by 2 and secant 0 is 1. So right hand side is also pi by 2. So at x equals to 1, left hand side is equal to right hand side. So this equation will have only one solution, and that is when the value of x is 1. So answer to this question is number of solution to this equation is 1, and that's your option B. Now here the question is number of integers x satisfying this equation, which is sine inverse mod of x minus 2 plus cos inverse 1 minus 3 minus x is equal to pi by 2. Now this is only possible if it is identity, and it is identity when sine inverse x plus cos inverse x is pi by 2. So this is true when x minus 2 is equal to 1 minus mod of 3 minus x, which we can write as mod of x minus 2 plus mod of 3 minus x, and it is equal to 1. And we can also express this as mod of x minus 2 plus 3 minus x, and it'll be x minus 2 plus 3 minus x. Now this is nothing but mod a plus mod b, and it is equal to mod of a plus b, which is true if and only if a and b they are of the same sign. So that means a and b should be greater than or equal to 0. So the condition that we'll get from here is x minus 2 into 3 minus x, it should be greater than or equal to 0. So there are two critical points, 2 and 3. This is minus, plus and minus. So this is true when the value of x lies between 2 and 3. Now we need to find integral values of x. So there are two integral values of x equals 2 and x equals 3. Now we'll put x equals 2, it will be sine inverse 0, and here it will be cos inverse 0, which lies in the domain. And if we'll put x as 3, it will be sine inverse 1, and here it will be cos inverse 1, which again lies in its domain. So there are two integral values of x possible, and they are x equals 2 and x equals 3. So number of integers is simply 2, and that's your option B.